Hello and welcome to the Sewer Game. In this game you can play the role of a water utility manager. The concept is based on the task required by a manager. You are in principle should assess critically the condition of the sewer system. You need to plan, to allocate budget and invest for the maintenance and growth of infrastructure of the sewer system. The objective of the game is to allow you, in the role of water utility manager, to understand the different consequences of the decisions made in terms of direct and indirect, social and environmental costs. Therefore, this game is developed to show and make you understand the consequences of making practical decisions for a more feasible, effective and sustainable sewer infrastructure. A case study of a real-life situation is adapted in this game for a simplified mode. This allows maximum flexibility and real case scenario in the decision-making process. However, the names, finance and model from the real system remains hidden and therefore this game is presented in a fictional context. The map on the right shows the city of Lucretius. It is a small island in the country of Prophytus. The land area is very shallow, flat and dominated by sandy soil. The yearly average temperature is 28 degrees Celsius. Currently, the city is experiencing sewer problems. At the moment, Lucretius has an outdated sewer system that was designed in the year 1970. In which, the projection on population growth was neither considered nor the future developmental expansion of the city. So, in this context, the current sewer system is much smaller, have too many inefficient pump stations and is inadequate to what is really needed or necessary. The sewer system, with a depth that ranges from 1.5 to 8.0 meters, is experiencing groundwater infiltration, salt intrusion, due to poor installation, and land subsidence. The lack of preventive measures and maintenance allows salt water to infiltrate into the deteriorated pipelines, which then hasten rapid pipe corrosion than what was not projected during installation. The sewer system in the red highlighted area is overloaded. The carrying capacity of the pipes are on its tipping point, almost to collapse. In this connection, the city is now experiencing wastewater overflow that creates floods. Furthermore, the newly developed industrial and commercial areas are not connected to the existing sewer network, blue highlighted area. The wastewater in this highly developed areas has to be transported with trucks to the wastewater treatment plant. The manual transportation of waste by trucks create traffic jam and a very undesirable odor to the community where it passes through. And also taking into consideration uncertainties when an untoward accident could happen with trucks full of waste. The situation of these two hotspots creates bad smells and health problems are increasing. The challenge is how to manage the existing deteriorating sewer system and plan to improve it in a feasible and sustainable manner based on the information provided. The modeling system in this game is used to optimize the target goals. As urban planner, you made an estimation of the future sewer system and its projected performance. The effectiveness of the system should quantifiable measures on how well the system behaves in relation to a number of indicators. The urgency of a measure to be taken will relate to the current cost and future operation costs as well as the future cost of implementation. Therefore an optimal strategy will lead to better indicators. The consultant assessed and evaluated the sewer system. Based on the feasibility study report of the consultant, the existing sewer system is expensive due to high operating costs and needs major repairs on the pump stations. The consultant firm divided the project area into 6 small catchments, A, B, C, D, E, F. As the sewer system is connected, changes in the system will affect the whole catchment. All solutions are based on deep gravity sewer. A deep gravity sewer is a sewer with a huge diameter, from 80 centimeters to 2 meters. The wastewater of the catchment area will be transported to the wastewater treatment plant through the deep gravity sewer of a maximum of 15 meters depth. If all catchments will be built in deep gravity sewer, the number of pump stations will be reduced from 62 to 22. The capacity of the treatment plant is just enough for the moment and the next 15 years. The game starts with the current situation of the sewer system. On the beginning of each round, 1 round equals 1 year, you will receive a story card and your yearly budget from the water fees. You either invest in the sewer network or save your money for the next round. If you made a decision for that year, then press the button for the next round. It is important to note that the variables mentioned below have been categorized in terms of capital expenditures, CAPEX, operating expenditures, OPEX, and impacts. CAPEX are initial costs which include capital investment costs for land acquisition, construction, or renovation and for the equipment needed to operate the proposed systems. OPEX are operating and maintenance costs which are ongoing cost for running the system. In the context of this investigation, these costs include all the operation and maintenance costs of all the pump stations in the section area. Impacts in percentage are based on environmental, social and sustainability. You have the option to upgrade your system, in the manner that best fits the current and future urban growth of the city. That is taking into consideration the cost and city budget, environmental and social impacts and the sustainability of the project. End of the game is after 13 rounds. You will win the game if the average impacts are 75% or more, and your total income is positive. Otherwise, you are going to lose the game. Now, start and enjoy the game.